card on this computer. Okay, so you can see a table in which some activities are listed, and then for each activity, three activity times have been given, and their immediately predecessor activities have been given. Okay, uh, so first thing is that, and now actually the topic today is, I want to just continue on that topic for the risk. Okay, so yeah, okay. I say something, there is some problem. I have to restart my Word. Okay, should work now. Okay, so this is some data which I have taken. Okay, so now these tools are working. Okay, so here you can see that this is the data which is over here. So this data is for the activity time. So the topic is actually risk in scheduling. Okay, so can you see me typing, writing over here with the pen?
Yeah.
Okay, so the topic is risk in scheduling. In this risk in scheduling, I am looking at a case when we are not sure about the definite time for the activity. So in this case, for each type of activity, we have three types of time. One is the optimistic time, the other is the most likely time, and the third one is the pessimistic time. Optimistic time is the time in which is the quickest possible time for that activity. Most likely time is in between the quickest possible and the uh, slowest possible time. Okay, so the slowest possible time is the pessimistic time. Okay, that is the slowest an activity can be finished. And most likely time is that time which you complete in most of the time. So optimistic, most likely, and the pessimistic time. So uh, these three types of times can be used. And these three types of times can be used when uh, there is a risk in the creation of the activity times. So that means if you see their description, then you will understand that most likely is that time. So for example, in say, if you do the activity 10 times, okay, out of 10 times, maybe 88 times that time or sometime around that figure will occur, okay? But only occasionally there may be a situation when the activity may be finished in a very short period of time. So that will be called as the optimistic time. And in also on a very occasionally, the activity may take much longer than complete. So that will be the pessimistic time. So optimistic, most likely, and pessimistic times may be estimated, okay, for the activities. So I want to use these times to create the network for this product. Okay, so for this purpose, one of the thing is that maybe what you can do is you can take the most likely time only in the network, and that one you can use in your calculation. And another option is you calculate the expected time. Okay, expected duration. So expected. Okay, so maybe I can say that it is ET. Okay, expected duration. So the general formula for calculating the expected duration or the expected time is like this. Expected time is equal to optimistic time plus the most likely time times 4 and plus the pessimistic time. Okay, and then divided by 6. So we take a weighted average of these optimistic time, most likely time, and the pessimistic time. So we give a weight of 4, that is 4 out of 6. That means about 66.67% to the most likely time, and then divide by 6. So this is the general formula for calculating the expected time. So based on this formula, if you calculate the expected time for each activity, so it will be for activity A, it will be 20 because 20 times 2 is 88. I just do some rough calculation over here. 88 plus 10 plus 22. So it is 120. 120 divided by 6 is 20. For activity B, it is all these 3 times are same, so it will be 20. Okay. For activity C, what will be that value? 40. So 10 times 4 is 40. 40 plus 4 plus 16 is 20. 40 plus 20 is 60. 60 divided by 6 is. Are you following it? 10. Okay.
Yes, we are following it.
Yeah. Okay. And then for activity D, then we calculate it. 2 plus 14, 14 plus 4 is 14 times 4 is 56. 56 plus 2, 58, and 32, and then 32 plus 2 is 34. So it will be what? 990 divided by 6 is 15. Okay, so activity D, it is 15. Activity E, it is 8, 8, 20, 32 plus 28. So it is 60. 60 divided by 10, 6 is 10. And activity F, it is again, activity F, it is 56. 56 plus, it is 8 plus 28, right? 14 times 4 is 56 plus 28. So 8 plus 6 is 4, 13, and then 84. 84 divided by 6 is, 84 divided by 6 is
14.
Is 14. Okay. And then this will be 4. This will be 48 plus 18. So 48 plus 18 is 6. And then 6. So it will be 11. Okay. 11. And then 16 times 4 is 64. 64 plus 40, 38 plus 6, 44 is 8. 8. And then 6 plus 4 is 10. 10 divided by 6 is, 10 divided by 6 is what?
18.
18.
18. Okay. And then 2, 8, 14 is 32. 32 plus 14 plus 2 is 16. 16 plus 32 is 48. 48 divided by 6 is 8. Okay. So that is 8. Okay, so this we did some back of the envelope calculation for that. Okay, that I think there's these values will be useful for us later on. So now we will draw the network. Okay. Okay, so for the network, I think we have these activities A, B, and C, which have no immediately preceding activities. So what we can do is we can draw this network A, B, and then we will draw this network by hand. We are not using any software for that. A, B, and C. These are there is no immediately preceding activity. Activity D, immediately preceding activity is A. Okay, so D has A, and then E has B and C, and then similarly F has B and C, G has B and C. Okay, so we can have E, F, and G. Okay, so B, C, B, and C, and then also from here B and C. Okay, so this will be like network like this. Okay, BC, BC, and then H has C. So H is also there. H has C, and I has G and H. So G and H. I is the here. I has G and H. Okay, this is how the network is shaping up. And J has D and E. So where is D? D and E. Okay, J, there is this J. J has D and E. And whereas F has no immediately succeeding activity. So what we can do is I can just only for the clarification, I can draw a project start milestone, okay, to link these activities A, B, and C with them. Okay, so this shows that this is project start is not an activity, it is just a milestone. And then similarly, I can draw for the clarity purpose a milestone. Oops, again, I draw it wrong. A finish milestone, project finish PF milestone. So J has no succeeding activity, E has no succeeding activity, F has no succeeding activity, and I has no succeeding activity. Okay?
Professor, E has the J as the activity.
Yes, so that was my mistake. So okay, now it's correct, I think. Yeah. Okay, so in this network now, what you can see is the network now. Okay, so for this network now we have several paths. So one of the path is ADJ, ADJ, ADJ is one path, and another path is BEJ. BEJ is another path, BEJ is another path. Another path is BF. BF is another path. Okay. Another path is BGI. BGI. BGI is another path. And then CGI is another path. Okay. And CHI is another path. Okay. And then CF CF is another path, okay? Yeah, CF is another path, and then CF is another path, and CEJ is another path, okay? Anything I'm missing? So for example, A, there is only one path, ADJ. B, there are three paths, so BEJ and BF and BGI, okay? So for B, there are three paths. C, there are also three paths, CEJ, CF, and CGI, okay? So yeah, then these are all the possible paths. So no, from C, there are four paths, and C, H, I, okay? Because there are four activities following from C. So four paths from C, 4 plus 3, 7 plus 8. Total, there are 8 paths, okay? So 8 paths. So longest of that path will be the critical path. Longest of that path will be the critical path. So for this, I think what I can do, I can just write this duration. A is 20 days expected duration, B is 20 days expected duration. So A is 20 days, B is 20 days, C is 10 days, D is 15, and E is 10, F is 14, and G is 4, G is 4, H is 11, H is 11, J is 18, and then I is 8. J is 18 and I is 8. Okay. So based on this information,
No.
what you...
Professor.
No,
yeah.
it's the other way. I is 18, J is 8.
J is 8, I
Yes.
is 18, and J is 8. Yes. So, okay, I can correct it. So J is 8 and I is 18. Yeah. Now is it correct? I think I'm okay. So based on this information, ADJ will be 20 plus 15 plus 8. That will be how much? This duration is 20 plus 50, 35 plus 8 is 43, right? And
Yes.
BEJ will be 38. BEJ will be 38. BF will be 34. BGI will be
42.
42. CGI will be
32.
32. CHI will be 21 plus 18, 39.
39.
And CF will be
24.
24. And CEJ will be 20
28.
plus 28. Okay. So out of these, the longest path is ADJ. So by this information, ADJ is the critical path. Okay, ADJ is the critical path. Okay, so this is the critical path. However, now the situation is that we are talking about the project management risk in the scheduling. Okay, risk in the scheduling. So in this case, this is just for our initial setup for the model, this is the critical path. However, what can happen is that the values of the each of the activities can range from 10 to 22, 20 to 20, and then 4 to 16, like that. According to the some distribution, the values can change. Since these values can vary, okay, these values are uncertain. So therefore, these values, ADJ, BEJ, BF, and like that, they are also not certain. They are also uncertain. So especially, for example, in this case, ADJ and BGI, they are very close to each other. So any slight fluctuation in these values may change this critical path. So ADJ, in some other situation, ADJ may not be a critical path, but maybe BGI is a critical path, okay? Because that may be the longer duration. So since the duration of the project depends on the critical path, that means the length of the critical path is the duration of the project. That is, in this case, 43 days is the duration of the project. But how likely is that the project will finish in 43 days? How likely is that the project will finish in 42 days, etc.? So this thing we can establish by using the simulation method, such as the Monte Carlo simulation. So now I'm going to set up this spreadsheet for the Monte Carlo simulation. Okay, so for this I need to open up this. I need to do the remaining work in Microsoft Excel. Okay, so for this work in the Microsoft Excel, I will open this sheet, and I think it will be better for me to copy this, whatever I have done over here, here in Microsoft Excel. So I will, let me copy this here. Okay, I think it's, I don't need it, but anyway, just copy it in Microsoft Excel. And then this other data. Where is this? Oh, what is that? Okay, and then I can copy it here. Okay, so now I can work in this thing. Okay, so now I have this Microsoft Excel sheet open, and then in this case, what I can do is I can set it up a Microsoft Excel. So I will write down, I will type the activity names A, B, C. Maybe I make it a little bit bigger. Okay, A, B, C, D, E, F, G, H, I, and J. Right? A, B, C, D, E, F, G, H, I, J. Okay. And then I write down their durations. So A is 20, 20, 10, 20, 20, 10. Okay. And then D is, where is D? 15, 10, 14. Okay. 15, 10, 14. 15, 10, 14. And G is 4, 11. 4 and 11. And then I is 18, 8. 18 and then 8. Okay, so I have this data, and then for ADJ, so now this is the activity data, and then for the path, I have path ADJ. So ADJ. So and these are the different paths. So maybe I can make them bold to distinguish them. ADJ. ADJ, the length of the path is A plus plus J. J is here. Okay. So let's make them central for better. Yeah, ADJ. So one path is ADJ is 43. Another path is BEJ. BEJ. So BEJ is equal to B plus E plus J is 38. Okay, next path is BF. BF is B plus F. Okay, 34. The next one is BGI. BGI. So BGI is 20 plus 4 plus I, 42. BGI is 42. Okay. And then CGI. CGI is 10. Plus G plus I. I is here. 32. And then CHI. CHI is 10 plus 11 plus 18, so 39. And then CF is equal to 10 plus 14 plus, I think, okay, CF is equal to C plus F is this 24. And then the last one is CEJ, which is equal to what? CEJ, which is equal to C plus E plus J, which is equal to 28. So now we have set it up. And then the duration, okay, which is the project duration. Okay, PROJ, project duration. Okay, project duration is what will be the how to set up the project duration over here. That will be the maximum of these values. Okay, maximum of these values. So from this column K to this column R, K to R. Okay, so this will be the maximum. So that will be the project duration. So in this way, I have set up the spreadsheet for calculating the project duration. So now what I want to do is that if I, for example, if I want to change something in this and then simulate the project duration, then I can do that. And then for this, I can use the model risk. Okay, I can use the model risk. But for this, I need to have these values, that is the distribution values over here. So then it will be better for me to it will be better for me to copy this data as well. Okay, so copy it over here. Excel, where is the Excel? Yeah, here is this Excel. So I can copy this data over here, right? Okay, so now if I want to use the model risk, okay, so what I can do is I can just make another copy of this data over here. Can you see this full width of the screen?
Yes, yes.
Okay. Yeah, so maybe I can make it a little bit shorter. Okay, so now is it okay better? Or maybe I can make it a little bit bigger, okay? Yeah, I think it's now it's okay. Yeah, I think now is okay. If is I make it a little bit bigger or all right. So yeah, this is the one. So now I want to apply the model risk. Okay, so in the model risk, that means I want to provide the distribution for the variation in these activity durations. Okay. So that means, for example, if it is 20, I want to, if it becomes 24. Okay. So for example, if it becomes 24, then how it will change. So for example, if it becomes 24, the project duration will become 47. And similarly, some other E values will also change. So therefore, this data will move out, okay? Will change, keep on changing. So, okay, let's put back to 20. So yeah, I can now simulate this model risk, okay? So I click this model risk. So, and then in the model risk, I will first select the distribution by this clicking this button in the select distribution. I will go to this common, and from this common, I will go to the triangular distribution. Okay, so this type of distribution which is used in these calculations, it is called as the triangular distribution. Okay, triangular distribution. So in the triangular distribution, the middle values are having higher weightage than the extreme values. Okay, so you can use this triangular distribution over here. Okay, so we want to apply this triangular distribution. Okay, so this triangular distribution. So I want to give this triangular distribution to activity B first. So first I will select this, the duration of activity A. Okay, and then I want to apply this distribution. Select the distribution, and in the common, I have this triangular distribution, and then I will click OK. So now I need to provide the parameters for this triangular distribution. So the minimum value is 10. So you will put 10 over here in this minimum column. The mode, which is the middle value, that will be 22. And the maximum is also 22. So 10, 22, 22. So after you input these values, then you will put it insert to the worksheet. So this value has been input over here. So it will be triangle 10, 22, 22. Okay. For activity B, there is no need to put it because it is not going to change. So you will not put any formula for B. For C, 4, 10, 16. So you will repeat it. Okay. So 4, 10, 16. Or otherwise, yeah. Okay. Maybe you can do it like this. 4, then triangular distribution. So it will be 4, 10, 16. So it will be 4, 10, 16. Okay, and then insert. So it will be 4, 10, 16. Okay. And then D. So we have to do it for D as well. So D is 2, 14, 32. 2, 14, 32. So it is, where is this triangular distribution? Go to the common. So it will be D is 2, 14, 32. So 2, 14, 32. So it is 2, 14, 32. Okay, and then similarly for E, it is 8, 8, 20. So what I can do is, maybe I can just copy these formulas over here. So it is, for example, this is 10, 22, 22. If you see this in the formula sheet, it is 10, 22, 22. There is no formula over here. Here it is 4, 10, 16, 4, 10, 16. D is 2, 14, 32, 2, 14, 32. And then since I just dragged it down, so it will be also as 2, 14, 32. But for E, it should be 8, 8, 20. So then I can change it from here. 8, 8, 20. So you can also change from here as well. So E is 8, 8, 20. And F should be 8, 14, 20. Okay, 8, 14, and 20. So it should be 8, 8, 14, 20. So you can change it from here. And G should be 4, 4, 4. Okay, so G should not be changed. So G should be 4. That is no formula for G. Okay, because G is 4, 4, and 4. H should be 2, 12, 16. 2, 12, 16. And I should be 6, 16, 38. So 6, 16, 38. Okay. And then lastly, J is 2, 8, and 14. 2, 8, and 14. Right. So this is the one. So now you can see that I am getting these values for the project duration, like over here is 46.3539, but this is based on these values which have been calculated. For example, if I re-evaluate it, then again, this value will change, okay? So the model has been almost set up. So the next step in the model risk is that to specify the output. Okay, so the output is this project duration. Okay, so output is project duration. So you will click this next to the here in this output, this down arrow, and then you will mark the output. So the output is this target cell. Okay, this is this one. Okay, so just to make sure, this cell is this. Okay. And this is the cell, and then the optional is to provide the name project duration. So the project duration is the name of this cell, and then click OK. So now the model has been set up, and now it's the time to run the simulation. So it depends how many, it is your choice that to run how many simulations, 1,000 simulations, 2,000, 5,000, whatever. So it's your choice. So default is 1,000. So just run these 1,000 simulations. And then the meaning of that will be that it will provide 1,000 different combinations of A, B, C, D, E, F, G, H durations. And then for each duration, it will calculate the project duration, and it will provide us some distribution. Okay, so now I am running it. I have clicked the start button. So 1,000 have been 1,000 simulations have been run. And here we have got this distribution. So we can now look at this data. Okay, so this data shows us that 1,000 samples have been 1,000 samples have been used, and out of these 1,000 samples, the mean value was 47.6. That means if this project is simulated for 1,000 times, the average duration of the project will be 47.6 days. And minimum project duration will be 35.12 days. That means it will be very unlikely that the project will finish in less than 35 days. Or the maximum project duration will be 63 days. It's also very unlikely that the project will take more than 63 days. Okay. The standard deviation in the duration of the project is 5.65 days. So the variability in the duration of the project is 5.65 days. So 47 plus 5.65 days, 47 minus 5.65 days. So this is the variability for the duration of the project. And similarly, some other factors. Here you have the percentiles as well. So here you have the percentiles as well. So 1 percentile is that 36.82. It means that there is only 1% chance that the project will finish in 36.82 or less days. Okay. There is 5% chance that the project will finish in 39.06 days or less. There is 25% chance that the project will finish in 43.45 days or less. So in this way, we can read through this data. Okay. So as we can see that for our normal situation, when we calculated that the project duration is 43 days, by the simulation, we have found out that there is only there is only about 25% chance for this 43 days duration, even less than that. Okay. So therefore, most likely, that means most likely the project will finish in like more than 47 days or more. Okay, because this is the 50%. That is more than 50%, about 57% of the time, the project will finish in more than 47 days, 47.006. So based on this, we can say that the expected, the better estimate for the duration of this project is about 50 days, 47 days with 50% chance for that. Or maybe we can even say that if I want like 75% confidence that the project is going to finish, then I should report that the project will take like 51.5 days to complete. So as you can see that it is providing us some very useful information. So this Monte Carlo simulation using the model risk is providing us some very useful information about how the project, how and when the project will be completed. Okay, so since we are using this model risk program, and unfortunately I don't have the full version of the model risk program, I only have the basic information. Therefore, I can only store a limited amount of output from this program. So for this, what I can store is I can go to this home tab of this result, and then I can click this report. And in this report, the full reporting features have been grayed out. That means I cannot select. The only thing which I can store is the create the report. For example, if I want to create the report in Microsoft Excel, so as a new workbook or the current workbook, I can select it, and then I can create the report. Okay, so this report is created. It will only show you the summary and this histogram. However, it will be even better if you, I think it is recommended that you should also store this statistics over here, but by just taking the screenshot of that. Okay, so for example, if I take this the screenshot of this statistics, new, and then I can store it. So I need to take the screenshot 2 times. Okay, this, and then you take the screenshot and save it in your Excel. So besides this summary, so this is because this basic version of the model risk is only providing you this summary. So these statistics are important. Okay, mean, minimum, maximum, and the standard deviation, and then these percentile values are also important.
Professor, could you show the next page of where the histogram is written? You see on the Excel. On the Excel, you've got the next page.
Oh yeah, next worksheet, histogram. Yes. Yeah. Here is histogram. Here. Yeah, histogram is here. So it will save the histogram, but that will be only as a picture.
Yeah, it doesn't have any information, right?
Yeah, that we cannot extract any information from that. So that is the problem. If we have the full version, then we can extract and then copy the detailed data as well. But since I have installed this program for a very long time, my full version, they only provided me only for 15 days. It has expired. So if you will newly install it, so then for the first 15 days, you will have the full access to this software, and then you can copy the full data. But after that, you will be like that, which I am now. So,
and Professor, could you please tell me, why did you choose the triangular distribution instead of normal distribution?
Yes, so for this, for the duration of the activities, the triangular distribution is the most likely, is the best distribution. We normally don't use the normal distribution for that. The reason is for when we calculate the durations, so we think about the activity of the duration in that way, something like most likely, pessimistic time, or the optimistic time. So we visualize 3 types of times only. Okay, but if we take this normal distribution, it is it will mean that the middle time will happen as a mean. But in this a triangular distribution, if, for example, your most likely time is close to the pessimistic time, so most of the value will happen towards the pessimistic time. So let me show you over here.
I got your point. So you want to say that in triangular distribution there is a kind of you can show the maximum time, the minimum time, and kind of the mean value. But
Yeah,
in the normal you only
actually
have an average, you only have a mean and a deviation, right?
Yes. Yeah. And
Okay.
yep. No, actually, what I wanted to say is that I forgot to just tell about that. There is actually a bias in the triangular distribution, and that bias is necessary. In the project situation, there is a more chance that the activity duration will be more than what you expect. Then there is a chance that the activity will finish early. So the triangular distribution provides us that kind of bias in that situation. Whereas when we take the normal distribution, then we are negating that bias. Negating will show that there will be equal chance of activity to be delayed than the same chance, and also the same chance that the activity can finish early. So that's why we don't use for the activity times, the normal distribution, okay? So in order to provide that bias that the activity will take, most likely take longer than what we think, we use the triangular distribution. So this may be the more appropriate answer, okay? That what I wanted to say.
Yeah, thank you. Got it.
Yeah. And next is, okay, so since we want to, you have performed this simulation, and then we don't want to lose the results of the simulation. So we will manually save this data by copy and paste of this. And then the next part, the next part will be that this one. Again, I need to copy it because I have very less space in this figure, and then these covering and new, and then I think I will take from 25 to this %, and then I will save it here. Yeah, earlier I did it for 15%, now I save it another one, 15%. So in this way, you will save your data. Okay, another view which you see from here that may be also useful is that from here, file, and then insert. Okay, yeah, insert. This cumulative ascending view may be also very useful for you. Yeah, so cumulative ascending view may be also useful. So in this case, for example, if you just move this data, then it will also show you some values. So for example, it will show you that at 6.9% over here, you get a value of 39.56%. So that means there is 6% chance that the project duration will be 39.58 days or less. So this view you can also look at over here, okay? So yeah, in this case, you can also have this. Okay, so 95% chance that the project will finish in 57.6 days. So that means if you want a 95% confidence that a project will finish, so you should report that the duration of the project will be 57.66 days in this case. Okay, so that is the one simulation. So you can run this simulation as many times as you like. And so, for example, in this case, we have run the simulation for 1,000 samples. So the mean duration was 47.63 days. If, for example, now, yeah, you can run this result. Sorry, you can save these results. You can save it as in your document. So you can say that simulation 1, you can save it in your wherever you want, simulation 1, and then you can also open it later on, these results. Okay, so you can open the same results later on as well. And then you can close it. And then maybe if you want to run now simulation for the second time, say, maybe second time you can run it for 10,000 samples, which is so many, which is quite a lot. It will take a little bit longer depending on the speed of your computer. But of course, it will not take much time. So do you want to save the current simulation results for the book? I already have saved it, so I don't need to save it. So you can select no. and then it will now run the simulation. It will, now you see, it is going to take some time, a few more seconds. Anyway, it will be producing results. So now you can see that the results produced are also quite relatively smoother than before, okay? But there is the result is almost the same, 47.71 days, okay? It's similar standard deviation and these kind of values. So with more number of simulation, you can just further refine the results. But generally speaking, after say about 10,000 simulations, the refinement in the result is negligible, okay? So in this case, you can use this result. Okay, so that was about the, let me close it. So that was about this topic. So how you can incorporate risks in the scheduling. Okay, so do you have any questions about this?
No questions. It's clear. Basically, it's clear.
Yeah, okay. So I think I have spent like this lecture and the previous 1 or 2 lectures as well on this topic. So now I am in a position to give this class a new assignment regarding this topic. So, and also I would recommend you to see on the Moodle. Where is this Moodle? Yeah, Moodle is here. The additional videos, okay? I already, earlier I mentioned as well, some additional videos on project scheduling, okay? So these are the videos which I taught in the last year's class after the pandemic time. So in those videos, I have also covered some of these topics as well. Additional videos on project scheduling, additional videos on resource allocation, and then like that. So you can look at this. Okay, so now about 15 minutes left. So another topic is the time cost optimization. Okay, I think maybe I will cover some more time on that topic as well in the next week as well. No, not next week is the holiday. Okay, after the break. Okay, I will cover some time. So time cost optimization. Okay, so this type of problem, I think last year I did this problem manually, but I think this year I will also try to, I need to first do it by myself as well, and then I will show to you. Last year I did this problem manually, okay, so that I can do it now. And then this year I am also trying to develop or just some illustrate this, how you can do this time cost optimization on Microsoft project. So if I'm able to do that, then I will also illustrate to you in the next class. So what is the time cost optimization? So time cost optimization is that when you want to reduce the project duration, okay, the cost will increase. The cost of project will increase. In this case, actually, it will be the direct cost. Okay, direct cost of the. So this is based on this assumption that when you want to reduce the project duration, the direct cost of project will increase. On the other hand, indirect cost will decrease. Indirect cost will decrease. So the total cost will have an optimization pattern. So total cost is the direct cost plus the indirect cost. Okay. So So for example, if we have this cost time chart, okay, if we decrease the duration of the project, the direct cost will increase like this. So the duration is more here, decreasing the duration of the project, the direct cost will increase. But the indirect cost will decrease, okay, with the reduction of the project duration. And whereas the total cost will be like that, okay. So the total with the total cost may first decrease and then will start increasing. So that this will be the variation of the total cost. We will add them together. So it will first decrease and then it will start increasing. So that will be the optimized value for the total cost. Okay. So this is the optimum cost, optimum project cost. Okay. That is the minimum possible cost for the project and that corresponding duration. Okay. So this is called as the time cost optimization problem. Okay. Time cost optimization problem. So this time cost optimization problem depends on the activity data. Okay. Activity data. So for example, maybe we can do this time cost optimization problem. Okay, so for example, if I take this network, if I take this network A, B, C, D, E, and say F. Okay. So we have 6 activities. Okay, if I have 6 activities, so I have this data for this. So activity A has 5 days of duration, C 3 days, B is 3 days, C is 4, D is 3 days, and E is 4 days, and F is 2 days. So if we have this kind of project, okay, say, and then activity, I have A, B, C, D, E, and F. And then I have this normal duration. Normal duration is say 5, 3, 4, 3, 4, 2. Okay. And in this time cost optimization, we have 2 types of duration for the activities. So we say that it is the crash duration. So what is the crash duration? Crash duration is that duration when we reduce the activity time, it is the minimum possible duration that the activity's time can be reduced. So it depends on the what type of activity. So for example, if normally we can complete this activity A in 5 days, we may also see that if we want to reduce the duration of that activity, we can reduce it up to say 3 days. Okay, so that will be the 3-day will be the crash duration. And similarly for B, maybe normally we can complete in 3 days, we can reduce it in 2 days. C is 4 days, maybe we can reduce it to up to 2 days. D is 3, maybe we can reduce it up to 2 days. E is 4, we can reduce it to up to 3 days. And then F is 2, we cannot reduce it. Okay, so all these are our assumptions, and it depends on the the normal duration and the crash duration depends on the type of the activity. So for activity F, we have assumed that activity F cannot be reduced. Okay, so there may be some activity like that as well. And corresponding to this normal duration and the crash duration, we have the normal cost. And say for the normal cost of activity A is 500. The normal cost of activity B is 600. The normal cost of activity C is 200. And the normal cost of activity D is 150. The normal cost of activity A is 400. And normal cost of activity F is 100. Okay. And the crash cost. Okay, so the crash cost is, for example, how that activity which normally take 5 days to complete, can be completed in 3 days. So that means we have to work quicker on that project. Working quicker does not mean that we ask the worker to work quickly. We may employ more worker, more human resources. We provide more. If we provide more human resources, that means we have to spend more on that. So therefore, in this case, we can say that if we want to complete this activity in 3 days, we have to spend more. So therefore, its crash cost, maybe we can say that it is 700. Okay. So the crash cost of activity B may be 700 also. Okay. Maybe, okay, you can say that it is, it can say 900, okay? Maybe you can say it's 900, okay? Anyway, I don't know, because I'm just taking data from the back of my mind, so some of the data may not be feel very appropriate, okay? So it will be 300, okay, maybe it is 200, okay, and then it is, say, 800, and then F is, because F we cannot crash, so its crash cost is not applicable. So in this time cost optimization, next step is to calculate the cost slope. So cost slope is the cost of increasing the activity per unit time. So the cost increase in this case is 200, and then 200 cost has increased 2 days. So that means it will be 700 minus 500 divided by 5 minus 3. So it will be 100. Okay. So it will be 900 minus 600, 300, 300 divided by 1 is 300. Okay. And then it will be 300, 100 minus 100 divided by 2 is 50. Okay, 50, and then 50 divided by 2 is 25, and then 400 divided by 1 is 400.
50 divided by 1.
Sorry, this is 50 divided by 1. Yeah, this is, yep, correct. 50 divided by 1 is 50. Okay, and then this is, we don't need to calculate it. So here in this case, there are 3 paths in this case: A, C, F, B, D, F, and B, E, F. Okay, A, C, F, B, D, F, and B, E, F. Okay, so path A is how long? 9 plus 2 is 11. And then path B, ABDF is 6 plus 2 is 8. And path BEF is 7 plus 2 is 9. So this is the critical path. okay, critical path. So ACF, if we want to reduce the duration of this project, so we will reduce the duration of the activities on this critical path, A, C, and F. So A, C, and F. So F, we cannot do anything because F is already, we cannot reduce the duration. So we can reduce either the activity A or C. So from activity A and C, we will say that the cost slope of activity C is 50, the cost slope of activity A is 100. So it is cheaper to reduce the duration of activity C, okay? So therefore we will choose activity C to reduce its duration from 4 days to 3 days. So therefore it's the duration of this path will reduce to 10 days. The other path will remain as 8 because there is no activity C, and then this will remain as 9. Okay, but this will happen at the cost of $50. Okay, so now in this case, still ACF is the critical path, and then we still can reduce the duration of C from 3 days to 2 days. So we will add further $50 more, and then the duration will reduce from from ACF from 10 days to 9 days. This will remain as same because we have not changed anything, so it will remain as 8, and then this will remain as 9. So now in this situation, we have fully if F was also F, we cannot consider in the analysis because F is we cannot crash activity F. But by reducing the duration of C from 4 days to 2 days, we have also fully crashed this activity C. Okay, so we will further not consider it in the analysis. Okay, so in our next analysis, we have 2 critical paths now, 9 days and 9 days. So therefore, we have to focus in not just one critical path, but these 2 critical paths. So ACF and BEF. So here we have, if we want to reduce the duration of the project further, so we have to reduce the duration of ACF and also from BEF. So from ACF, we have activity A is the only choice, which is 100. And from BEF, we have B and E. B is 300 and E is 400. So B and E are both much expensive than activities B. But now it is very difficult to crash it. But anyway, we still can choose A from ACF and B from BEF because B is 300 and E is 400 at this cost slope. So therefore, we will spend like plus 100 and plus 300 for further crashing. Okay, so A was reduced by 1 day, so it will become like 8 days. And now it is 8 days, and it will also become 8 days. Okay, so B has reduced from 5 to 4 days, and sorry, A has reduced from 5 to 4 days, and B has been fully crashed because from 3 to 2, it is now fully crashed. So we will further not consider B. And then, yeah, of course, there was B over here. So I think, yeah, this will be 7. This will become 7. Okay. Yeah, big B was reduced. So now B has been fully crashed over here. So again, now we have ACF and BEF as the paths. So if we want to further reduce it, so then I will spend 100 for reducing A and 400 for reducing E. Okay. So by this, A will be fully crashed because earlier we reduced 1 day for A, and A will be fully crashed, and E will be fully crashed. So the duration will be 7 days, 7 days, and 7 days. So at this point now, the duration of the project has been 7 days. So we cannot reduce the duration of the project any further because we have to follow these paths. For all of these, one of the path has been fully crashed. Okay? A BEF has been fully crashed. There is no chance of reducing any duration of any activity over here. ACF has been fully crashed. There is no chance of reducing any duration of this project. Only BDF has not been fully crashed, where there is some crash available for activity D. but that is not useful for us. There is no point of reducing the activity D over here. So in this case, our final result is that by spending these extra amounts, 50 plus 50 plus 100 plus 300 plus 100 plus 400, we are able to reduce the duration of the project from 11 days to 7 days. So this is the extra direct cost which we have spent. Okay. On the other hand, there will be the indirect cost, which will depend on the total duration of the project. The duration of the project will reduce with the indirect cost. Okay, so this was just the brief introduction, and I think some of that I have also mentioned in those additional videos as well. So maybe if you want more information, you can look at that additional videos as well. And since the time is completed now, so I will stop at this point, and then I will continue this example, and then later on I will also want to introduce you to the PERT, okay, PERT technique, okay. So in the next, after the break, we will continue this time cost optimization example and the PERT method. Okay, so they will that I will also introduce to you. Okay, so see you after the break. So do you have any question?
Yes, can I ask a question?
Yes.
Is this cost slope is the cost per day?
Yes, cost increase per day. Cost increase per day, okay? Crash cost minus normal cost divided by the normal duration minus crash duration. So that's why I did this first formula like this, and then the others can be calculated like that.
Okay, thank you.
Yeah, and some of the books mention these cost, crash cost and crash duration in some little bit other way, but the meaning, real meaning is the same. But I don't have time to explain it right now, so I will explain it more in our next class. So see you after the break on 1 week break, and then hope you have an enjoyable holidays.
Thank you, Professor.
Thank you. Bye-bye.
Professor, just 2 minutes. Can I ask a question?